Hello everyone, my name is Oleksandr and I want to present our paper which called Integration of Decision-Making Models for Decision Support System of UAVs Operator in Emergencies. Authors Tetiana Shmelova and Oleksandr Burlaka. Unmanned aerial vehicles have a number of advantages, namely low cost of operation, stability and flexibility, simplicity and availability of technology compared to manned aircraft. In logistics, as the safe, cheap and fast method of transportation of cargo, for aerial photography, for controlling road traffic. The purposes of work are decision-making algorithm of UAVs operator in an emergency or in pre-flight programming on autonomous UAVs flights, decomposition of the process of decision-making by UAVs operator in an emergency, working out of models decision-making by UAVs operator for the search of the optimal solution in emergency. On the pictures below you can see the integration, risk and uncertainty decision-making models in certainty model. Emergency situation may occur when flying both in manual and in the autonomous control. For operation carried out manually plays an important role in the human factor, and a significant part of emergency was due to the wrong actions of the operator. Here you can see the developing of shell model from usual shell, which was developed in 1972, to artificial intelligence, which we use nowadays. Let's briefly, here you can see the evolution of shell model from 1972 till nowadays. As you can see, there are 5 stages like professional skills, cooperation in team, culture, safety, efficiency, and collaborative decision making. Let's briefly look at the basic principles of decision-making modeling in emergencies. Types of UAV flights and UAV control. First, degrees of autonomy and controls of UAV flights. Under mode by human operator, autonomously by onboard computers, piloted by an autonomous robot. Second, for the control of the UAVs using the next schemes of UAVs control. Operator, single UAV, group of operators, group of UAVs, and operator through central drone repeater, which we call CDR, as a group of UAVs. For decision making in the selection, optimal alternate aerodrome place or vertiports. In the case of emergency landing, need the next output data. Calculate route of direction, an aerodrome of departure and its characteristics, an aerodrome of destination and his characteristic, a list of alternate aerodromes according to the calculated route, a type of RPA and its tactical and technical characteristics, current flight situation, difficult in conditions of flight realization, difficult situation, additional factors that influence on air traffic. This is an algorithm of calculation. You could take a look and then find it in our paper. There are results of expert estimation of finding an optimal landing aerodrome place or vertiport for approach in emergency using different criteria like meteorological conditions, distance of RPA to the airport of departure, airport of destination, tactical technique characteristics, availability of fuel energy on board of RPA, reliability of C2 lines for connection with RPA, possibility of communication with ATC units, subjective factor, logistics, aeronautical fees, priority of AP. And in tables you can see results of expert estimation. Let UAV perform the target task at a certain stage of the flight, probable, extraordinary, and emergency situation. For example, loss of control, engine failure, bad weather conditions, and it is some risk to lost UAV. ATC decides in emergency using technological procedures assist, acknowledge, separate, silence, inform, support, and time. For example, finding an optimal landing aerodrome place or vertiport, an aerodrome of departure in A1, an aerodrome of destination A2, alternate aerodromes, vertiports AC1, AC2, AC3, for return operation in the case of emergency station that is caused by meteorological conditions. You can see top left figure. Emergencies may occur when flying both in manual and autonomous control. For operation carried out manually, plays an important role in the human factor. There are presented some results of calculation by Wild, Hurwitz and Laplace methods. You can see optimal places highlighted in red color. Conclusion. Presented human factors problem, evolution of human factors model, the synergetic effects, the integrated models for effective decision-making by UAVs operators. Algorithm defining an optimal landing airport place or vertiport for UAV in the emergency, given an example decision-making in emergency with UAV in approach to destination in bad weather condition. The evaluation of factors that influence the selection of optimal landing aerodrome is realized with the help of the expert judgment method. The decision of selection task of an optimal landing aerodrome place vertiport and emergency landing by means of the criteria Wald, Laplace, Salvage, Hurwitz, decision making in uncertainty, and decision tree, decision making in risk obtained. At the below you can see our books which are published in United States. You can find it on this website egglobal.com. Thank you for your attention. Goodbye.